Okay, so we were defining our function, training function, right? So it will have its parameters as tokenizer here, and which already we have defined tokenizer, right? And it has some files. Files will be the training corpus, right? And vocabulary size we have to define here, and the minimum frequency, right? We have to provide, like what should be the minimum frequency for a token which we will consider, right? And vocab size is what is the target vocab size we want in our after the training in our tokenizer, right? And we are taking vocabulary size is similar to 32K because there is a trade-off, right? Like if we have larger vocabulary size, right, then we have we will have longer subwords, right? Because it will increase the vocab number of tokens, right? Like pillage, it will consider them as different words, right? Then we have the fewer tokens per sentence because we have subwords, longer subwords as tokens, right? If we have fewer tokens per sentence, then we will have shorter sequences, and it will provide us the more efficient context uses, right? But there is a problem also. Larger vocabulary needs a larger embedding matrix, and if we have larger embedding matrix, then we will have to get more model parameters. So because our model is only around 120 million parameters, right? So vocabulary size matters here. Okay, so let's say we have this wait a minute, we have this vocabulary size of 32,000, right? Then if let's say embedding dimension D is 768, so number of parameters, right, would be something like 32,000 into, it's like V cross D, right? Say 768, it will go for like 24576, like something like that, approximately, right? It will something like 24.6 million parameters, right? So that's all there. That is already a large fraction of our model, which we are trying to build of 120 model parameter model, right? And this is why tokenizer vocabulary size is not merely the pre-processing detail, right? It affects the model architecture in itself. And I already told you this minimum frequency thing. So that this means that we can ignore the very rare pairs we get, like if that pair had very many, let's say minimum frequency is 2 or 3. So if some pair is counting only occurring like 2 or 3 times only, so we can ignore that. This can reduce the noisy or unnecessary vocabulary entries in our tokenizer, right? Okay, then we are defining special tokens because we have to define them before, right? This will tell the trainer to reserve the special tokens we defined earlier, right? The next thing I will define here, guys, is just a minute, I will do that also. And okay, so we are not just defining the trainer here. What we will do, we get the uh, BP trainer, right? What we imported here, this BP trainer, right? We can take it. So BP trainer we are taking, and in that I can define these things, all of these things, like vocab size is vocab size, and we will have minimum frequency is equal to minimum frequency only, right? And special tokens we can do this. Special tokens is special this one, right? And next thing I can do is to show the progress. So progress is I can define it as true, right? So this show progress will simply display training progress. It's very useful when we train our models, right? And it will give you the real experience, right? Then, so you see, file is just a list of paths, right? These files. So trainer streams them, doesn't load all to them. Okay. So these files we are getting is I have to define that also, right? Right. So tokenizer I have to train a tokenizer on the files and with the help of trainer, right? This trainer I have defined here, BP tokenizer it is. So based on this BP trainer, this is where library usually actually trains the BP. Okay. So conceptually, what it is doing. So what it will do, it is doing the same thing we did manually, right? It will read our corpus. Okay. It will read the corpus. Then it will build initial symbol representation, right? Like character label, right? Initial symbol representation. Then it will count adjacent pairs, right? Then after counting these adjacent pairs, it will merge the most frequent ones, right? Merge most frequent pairs. Then what it will do, it will repeat this process. After the end, the number of rounds we have defined, it will construct the vocabulary at the end, right? Vocabulary, and it will also save the rules. So the difference here is that this production implementation is optimized here, right? So what I can do here now, after this I can return the tokenizer. So we will get this tokenizer after the training, right? Okay. So we train the tokenizer and return tokenizer here, right? Then next thing, guys, we will validate. So a tokenizer is not finished simply because training is completed, right? We need to ask that that tokenizer that, okay, does it work well for English or not? Does it work well for Hindi or not, right? And Marathi and all, right? So does it handle mixed language text? So we need to ask each and everything in that case, right? So our script explicitly chooses two important matrices here, right? So let me build a function to validate it. Okay. Okay. I will define a function validate, right? It will take the tokenizer as input, right? And after taking the tokenizer as input, so what is this function is all about? We are doing a sanity check, right? Check coverage on each language, right? So why we are doing this? Because a good multilingual tokenizer has multilingual tokenizer has this has unknown ratio close to 0, right? So it can represent the script, and it will have the low fertility, right? So what does it mean, ratio? Like it can represent the script, whatever script we give it, right? And it will have low fertility. What is low fertility, guys? That means like it will take few tokens per word, right? It's efficient. Few tokens per word, because if you it is like taking more tokens, then it is like character level tokenizer only, right? So it was not like very efficient in that case. Yes. So first what I will do, I will take some sample, right? Then I will check on that samples. So first this is samples, right, equal to, let's say this is samples dictionary. I am tagging this as English, right? And this is like, okay, the quick brown fox jumps over the lazy dog, right? And if I take some Hindi, right, Hindi, then how to write Hindi here, guys? I don't know. I have to take some text from somewhere else, then I can write it here, right? Let's say here I can paste it here, right? So this is some Hindi text I have from somewhere. Okay. So it's very, if I have some Marathi also, right? So it will have this thing, me, like okay, this is some Marathi text. मी दररोज सकाळी व्यायाम करतो आणि पुस्तक वाचतो. And then I have mixed also, some mixed text, right? It will be like मुझे कल ऑफिस जाना है, so I woke up early. This is like that. Okay. So alright. So this is mixed, guys. So we are intentionally testing here that English, Hindi, and Marathi and mixed language text. So mixed example is particularly useful because our final model is multilingual, right? So we have to test this very okay. So then what I will do, just a minute. Okay, I can print something here first, right? Print like what we are doing a tokenizer migration, right? So report, we will print some report, right? We initialize a dictionary for report. For language, right? And we will have some text in this samples dot items, right? And this language is whatever it is, right? So first what I will do is I will have to convert the raw text into the tokenizer encoding object first, right? So let me do it. Encoder is equal to tokenizer dot encode text. What does it mean like? So this object, this ENC will contain information such as tokens, IDs of the tokens, right? After that, whatever like. So first it will encode the text in the tokens, and it will provide some IDs to the tokens, right? Okay. Alright, then what I will do is I will check, okay, how many tokens I have in this like first text, right? So in tokens, how many tokens I have provided, length of encode dot tokens, right? I will get the tokens of the from this, how many tokens I have. Then like what I have to do is like how many unknowns I have counted, right? So n UNK is ANC dot tokens dot count, right? How many UNK I have counted in this. So this will count how many tokens are unknown, right? Then I will find out the unknown ratio also, like n UNK divided by n tokens if n tokens is right, is there, else it's 0, right? So it's a right, so that is like this. So number of UNK tokens divided by number of total tokens. So let's say I have 2 unknown tokens and 100 total tokens. 2 by 100 like 0.02, 2% of unknown, right? So for a multi-language tokenizer, we want this case as close to 0, right, as possible. So this UNK ratio matters because suppose let's say Hindi has UNK ratio of 20%, let's say for example, right? Then that means that 1 in every 5 tokenizer outputs is unknown, right? So that is a catastrophic for a Hindi language model. So the model cannot learn patterns that the tokenizer cannot represent, right? So tokenizer coverage is like available information and it will define the language model quality. So this is why UN key ratio is such an important metric here, right? So tokenizer coverage, the fertility is matters, right? So now what I will do is how many words I had, right? So n words is equal to length of text dot split. So it will give me how many words, right? If I have these number of words, then I will count the fertility. I can calculate fertility is equal to how many tokens divided by n words, right? If n words are there, else 0, right? So fertility means average number of tokens per word, right? If I have like equal number of tokens as words, then fertility will be 1, right? That means one word, one token per word it is there. So let's say I have 20 words and 60 tokens. So 60 by 20 is like 3 tokens per word, right? Fertility also matters. Let's say suppose English has fertility is 1.3 here and Hindi has 5. Okay, what that just mean? This means the Hindi is being split much more aggressively, like 5 tokens per word for the same context window. Like let's say for example 12 tokens is there. English may represent many more words than Hindi. That can become a multilingual fairness issue also. Okay. Yeah. So context window is the example. Like suppose the model has context length is equal to 500. Let's say here. Okay. So let's suppose context window here. Context length. Let's say model has this 500 tokens of the context length tokens, right? If English fertility is 1.3 tokens per word, then it will approximately go for 512 by 1.3, which makes approximately 394 words. So this is the context for English here, right? It can fit these number of words, 394 words. But for Hindi, 512 by 5 is 102 words only. So tokenizer changes how much semantic text that the model can see inside the same context length, right? So that is a very important connection between tokenizer design and transformer behavior also, right? So it is only covering the 102 words of if it is like fertility is 1.3, right? So yeah, this is like okay. So fertility matters, guys. Average number of tokens per word we have, right? Then what I will do is I will print the report also. Alright. This is like report based on the whatever the language tag I am getting here, right? Equal to this. Report is like okay. Tokens is n tokens, right? Tokens is n tokens here, and UNK ratio is like UNK ratio here, and fertility, right, is a round of fertility to, let's say, right? So this is our report creation, right? We are storing number of tokens, we are storing unknown ratio, fertility. This makes the result machine readable. Then I will print the results, whatever result I will get according to the report, right? So next thing what I will do is print if a string of language it is, right, and tokens 3D, right, tokens, okay. Then I will have again string UNK ratio on the 1%, right. Then I will have again a fertility is fertility whatever it is on to round to 2.2f, and tokenization per word is the, okay, right, that is the printing. This produces is something like 12 tokens, let's say, right, UNK something like that, whatever it is, okay. So eight spaces is giving, like before that is, okay. Okay, then also I will print the token example also, okay. So after this I can print, right, whatever encoder dot tokens, right, let's say first 12, right, right, and next thing is no, whatever if and tokens greater than 12 else empty, right, okay. So this will allow us to actually see what the tokenizer is doing, okay. Okay, so this is important. So a tokenizer shouldn't be treated as a black box. So we have to see like what the tokenizer is doing. Okay, then I will define our main function. Okay, which will provide everything now. Okay. So this will be our entry point, okay. First thing I have to get is the argument parser, right. Argument parser is equal to arg parse, right. Argument parser I have given. So what it will do, it will create a command line argument parser for us instead of like hard coding everything in Python. So we can run like some files and everything, right. Okay. Then we will have arguments, right. Argument parser I have ep.argument. I am adding some argument here. So first it's data. Okay, what this is mean? What is required, right? Data is required, right? And then we have an args, right, is equal to plus. What does it mean here? Okay. oh, here, like this. So this NR plus means that we can provide one or more files. Plus, that is why we are giving plus. For example, dash dash data is required, and we can give english.txt, we can give hindi.txt, we can give marathi.txt, we can give multiple files as input, right guys? Then I can give it like required is true, which is data is required, right? Next thing I can give a help is equal to something like it will take okay what is needed if we don't pass the argument, right? So we have to give like instructions, one or more some clean corpus .txt files, right? Yeah, we are providing it here like this, and that's it. Then after this dp.add, what I will do is we have to specify some like output directory, okay guys? So next thing I can do is app.add argument, right? Is like output directory I am defining like tokenizer output, okay, here. So what is this? If we don't specify an output directory, okay, so if we don't specify that, then we can defaultly use tokenizer output as a directory, okay? It will create that if we don't specify any, okay? Then what I can do, I have to specify the vocabulary size, right? What vocabulary size I want in the argument also. So argument parser dot add argument, it's like vocab size, right? And type of this vocab size is integer, and default will be our 32,000, right? And next thing, int means like argument must be treated as integer. Then I have to define the minimum frequency thing also, right? Add argument as minimum. Here this is like we can do whatever, right? This is frequency, and type is equal to integer, and default is 2 here, okay? Alright, and after that I will have like arguments. I will take the arguments here. So arguments is equal to app dot parse args, right? So now Python will read what we typed in the command line, and it will store the values in args, right? And I will create the output directory, okay? Out is equal to path, whatever path I have given, args dot out, right? And out dot make directory exist. If it is exist already, then true. Right? If the directory does not exist, it will create it. If it exists, it will not recreate it. It will use that. Right? So it will not throw an error if it already exists. Right? So output directory is created, whatever we have passed here, right? It will take that, whatever path we have given, and this out, make directory here, alright. And next thing what I can do is I can build the tokenizer, right? First of all, this is my tokenizer is equal to build a tokenizer first. What is this build a tokenizer function? You can see here. Build tokenizer, it will assemble the untrained BP tokenizer, okay, which is configured for 3 languages, and the tokenizer is here. So tokenizer BP UNK is unknown token we have defined already. Tokenizer to normalize norm sequence NFKC. Right? NFKC, you know already what is normalization of the sequence. And pre-trainer, pre-sequence, white space, punctuation, behavior, actually state, right? Whatever it is, it will pre-tokenize the sequence, then it will return the tokenizer, right? So this is our tokenizer defined. Build it, then based on this, I can train the tokenizer, right? So we have created the tokenizer architecture. Now I will train the tokenizer, right? Then TOK is equal to train whatever the tokenizer I am given, args.data, right? This is the files paths, right? args.vocab size I am giving here, right? And args.minimum frequency, right guys? So this is our training now. So now I will save the whole tokenizer to a single JSON, right? So what I will do, I have this function called tok.save, right? str in the output / directory, right, with the file name of tokenizer.json, right? This will save the whole trained tokenizer into the JSON file. So this is very useful because later we can simply load that tokenizer. We don't need to train it again, right? And this is the tokenizer. This tokenizer means the rules. It has a list of the rules, right? Then we will save the vocabulary and special tokens, right? Token to ID mapping of the report for the reporting, right? So what I can do is with, right, open out / vocab.json. It will open this file, right, with the write mode. Encoding is equal to UTF-8, right? Right. I am creating it, opening it as F. So JSON.dump, whatever the tokenizer we have, we will get the vocab from that, right? Get vocab and write it in F, right? Ensure sky is equal to false, indent is equal to 2. So this will create the vocab.json file here in the output here, right? So it will record the mapping between tokens and IDs, like what token, just you, let's say this UNK get 0, then play get like it's a 2001, and better gets like better gets something 2005. So like this, right? Each token will get ID in the vocabulary at the end, right? So conceptually token is belongs to some integer ID, right? Let's take some example. Let's say there is a token called hello, right? It gives some 1 2 3 4 ID, right? Let's say namaste some is token, right? It gets 5 4 2 or something like that. So the exact ID depend on the trend vocabulary, and we are giving like, okay, ensure sky is equal false, right? What is it? So in this, what it will do, because our vocabulary contains Hindi and Marathi, right? So we want Unicode characters to remain readable instead of being unnecessarily escaped. Okay, so ensure sky false is useful for multilingual vocabulary, right? Then one thing I can do is I can print out the special token mapping also, right? So with open / special token map file .json, we are W here, right? And encoding is UTF-8, right? We have created that file. Writing mode, what it will do, json.dump, I will create this file, and it will go T in token to ID, T for T in special tokens, right? F comma intent is 2. So it will give us token to ID of T is the token, right? And it will give the token ID of the token from the tokenizer for us, right? Then this will save the mapping like special tokens, so you can very useful later, right? Then what I will do is I will validate the report. Okay, so report is equal to validate the tokenizers, right? Whatever the tokenizer is, we will test the tokenizer about the fertility and all, right? So it will report us with the language also. Then I will save the validation report also. Like with open, right? In the output folder only, and validation report.json, right? This is writing mode. Encoding is UTF-8, right? I am creating this file, and as F. Okay, then what I can do is json.dump, right? Report comma F comma. So I will save the report in F, and I will ensure the sky as false also here, and indent is 2. Okay, this means that our validation results are stored in the disk, whatever the result we get, and this gives us this will give us the reproducible evidence for the project report, right? And finally I can print something, right? Like I can say, okay, print like I have saved tokenizer to out slash, right? And next thing, vocab size equal to tok.get vocab size, right? So it will give us the vocab size also, right, in the tokenizer. And okay, after this I can do is like if name is equal to main, right, then only you can access the main here, right? Alright guys, this is our is build, right? We will tomorrow we will collect some data, right? And then we will get the training of the tokenizer. Okay, so thank you so much for watching, and we will meet you tomorrow. Alright, thank you so much guys.